Assalamualaikum and a very good day, class. So we'll go to chapter 2 of numerical methods, which is for this chapter, we'll go to the topics of roots of equations. First of all, we go to the outcomes of this topic. By the end of this chapter, all of you should be able to find the roots of equation by using the first method is graphical approach, and the second one is by using incremental search. And then next, you need to know how to find roots of equation by using bracketing and open methods. Also, you should be able to provide a comparison between bracketing and open methods, and you need to relate this topic with chapter 1, which is you need to calculate the approximate and true percent relative error that you have learned in chapter 1. So all these are outcomes for this topic. Next class, we go to the content. The first one, I will go to the introduction, and then I will go to the methods of finding root of equation. That is, in this chapter, you will learn the first one is graphical method, and then you will go to incremental search, and I will go to the bracketing, and in bracketing we consist here two types of method, bisection and also false position method. Then class will go to the last topic here, which is open method. And in open method, there are two types of method, which are the first one is Newton and the second one is second method. First, we go to introduction. Mathematical model in science and in engineering. Mathematical model in science and engineering involve equation that we need to solve. Equation of one variable we can write as function of x, which is equal to 0. So here, first here we need to make our equation which is here function of x. We make it equal to 0. From here, you need to solve this equation, means that you need to find roots of this equation. Finding roots here means that we need to find the value of x when our fx equal to 0. And this equation 1, it can be in the form of linear or nonlinear. And when we solve this one, means that we find it here, what I mentioned previously, the values of x that satisfying the equation 1 means that we find the value of x when our function of x here equal to 0. So class, the equation here belong to one of the following types of equation. So we have here three types. The first one is algebraic equation, and the second one is polynomial equation, and the third one is transcendental equation. Transcendental equation, it is a non-algebraic equation which can be in the form of trigonometric function, exponential function, and also logarithm function. So these are the example of types of the equation that we have discussed previously. For example, algebraic equation, actually it can be in this form, means that we have here function in terms of x and y only. For example, we have 4x minus 3x squared y minus 15 equal to 0. And then if we have here fx in terms of ax to the power of n, let's say this is an plus an minus 1 x to the power of n minus 1 plus a 2x to the power of 2 plus a1x plus a naught, which is equal to 0. So this kind of function, we call it as polynomial function. For example, here we have x squared plus 2x equal to 4 equal to 0. So in this case, it is in terms of polynomial function, that is, we consider polynomial function of order 2 because the highest power here is 2. And then transcendental equation. Transcendental equation means that the equation that consists of non-algebraic terms. For example, here we have either sine or trigonometric function, we have logarithm, we have exponential function. So here you can see you have sine 2x minus 3x equal to 0. So here involved, this one is trigonometric function, means that it belongs to transcendental function. So if I put here, for example, tangent of x equal to 0, so this one also transcendental equation because here we have trigonometric function. If we have here, for example, exponential of negative x plus sine of 2x equal to 0, this one also transcendental equation because involve exponential and also trigonometric equation. And then class, we go to the concept of finding roots of equation. What does it mean by finding roots of equation? If you have, for example, here a function of ax square plus bx plus c. So when this equation we make it equal to 0, you have learned previously we can find roots of this equation. That is, we find the value of x. What is the value of x when our fx equal to 0? We can find this x by solving this equation. But how to solve this one? This is quadratic equation that you have learned in secondary school. And to solve this, we can use the first method, factorization. And also we can use here completing the square method or quadratic formula method. But what you have learned previously, it is analytical methods. It is not numerical method. In this subject, you will learn how to solve or how to find this x when our function of x equal to 0 by using numerical methods. Why? Because some equation here we are unable to solve it using these three types of method or using the analytical methods because the function here it is not just quadratic equation. So class, all above mentioned methods actually used to solve quadratic equations only, and that method to solve this we call it as analytical method. The solution obtained if we use analytical method, we call it as exact solution. But due to the complexity of the equation in modeling the real life system, so the exact solution are often difficult to be found. Means that in this case, require us to use numerical methods. And the solution that we obtain by using numerical method, we call it as numerical solution. This is what you will learn in this topic. Means that you will find here the value of x. Okay, you will find x when fx equal to 0 by using numerical methods. And the solution that we obtain here means that x that we obtain here, we call it as numerical solution. So class, numerical method that we will in this topic, there are three types of numerical method that we will be considered to find this root of equation. The first one class, you will learn incremental search. But before you go to this incremental search, you will learn here a graphical method. Graphical method, it is not a numerical method. Graphical method, it is a graphical method. Means that you need to plot a graph to solve the problem. But for the numerical method, we will start here with incremental search. Before you learn this incremental search, you need to understand first graphical method. And then class, from this incremental search, we'll go to the bracketing method, which consists of bisection method and also force position method. And then, because some of the cases need open methods, so class we will learn also how to find roots of equation by using open methods, which consists here Newton-Raphson and secant method. So before we go further to all these numerical methods here, we'll learn how to find roots of equation by using graphical method. First, we go to the introduction of the graphical method. Graphical method is the simplest method method, the given function will be plotted on Cartesian coordinate x, which is here. This x will give us values of roots that satisfying fx equal to 0. And x, which is value of roots that satisfying fx equal to 0, provide approximation roots for the underlying equations. And fx can have actually one or possibly many roots. What does it mean here? Graphical method means that you need to plot a graph. When you plot a graph, you will plot a graph of that function on Cartesian coordinate. What does it mean by Cartesian coordinate? Cartesian coordinate refer to the rectangular coordinate or the graph that you plot on x and y axis, which consists here positive side of x-axis, negative side of x-axis, and also positive side of y-axis and negative side of y-axis. And this y also represented as function of x. And when you find the roots, for example, I have here graph fx equal to x squared. When I plot this one, I will have actually the graph like this. So finding roots, you will find the value of x that satisfying, which is here, satisfying this function equal to 0. When this function equal to 0, on the graph you can see that it equal to 0. Function equal to 0 on this location. Okay, means that here when fx cross x axis. In this case, in this equation, you can see the graph will cross x axis at this location. Means that this one is root of this equation. Class, we go detail here. For example, we have this kind of figure. You can see this is our fx. This is our function, which is given by quadratic equation. And you can see it is cross x-axis at this location. Means that here x equal to negative 2 is root for this function. And because of the equation cross at only one location, so the solution for this graph, we said it has only one solution. But when we go to the second figure here, you can see it cross x-axis at this point and also at this point, which is here is 1, here is negative 3. Means that here we have two values of x equal to 1 and x equal to negative 3 that make this function or this graph cross x-axis. So in this case, you have two solutions. And class, if we refer to the third figure, we can see here there are many locations that our function cross x-axis. First one, second, third, fourth, okay, fifth, seven, six, seven, and also this 8. If you plot again, it will have many rows. So in this equation, in this function, we can say that we have many solutions. Means that here I can summarize, our solution can be one solution, can be two solutions, or can be many solutions. So it depends on the graph that you obtain, whether it crosses the x-axis at 1, at 2, or at many solutions. Class, we go to this example 4. You need to find roots of equation fx equal to x squared minus 8x plus 3 by using graphical method. Of course, the first step here, you need to know how to plot a graph. I will show you how to plot a graph manually later, but class, nowadays we have a lot of software in plotting graph. So now, we will use software. So based on that, you will go here to the GeoGebra software, which is the link is given here. So now, this is GeoGebra link. This is GeoGebra interface. And if you see previously, we have a function x squared minus 8x plus 3. How to input a function? You can click here. You can see this one is like calculator. So we can click here. We have x squared minus 8 times x plus 3. So we can see directly GeoGebra will plot a graph for us. Once you got this figure, so now we want to have a value when this fx cross these two x-axis. So how? You can go to this one. This one is actually intersect point. You can go here, click intersect, and then you click on the graph here. You will see for this one, it is when f is 0, the value of x is 0.39. And here you can click this one. When f is 0, the value of x is 7.61. So this is how can you get the roots of equation based on graphical method. And now, in the next example 5, you need to find roots for fx equal to cos x plus sin 3x, where here x in between 0 and 4 pi by using graphical method. Here you need to plot a graph. Again, we plot in GeoGebra. We have here function cos 3 times x plus sine of x. But now the question, we want our graph just appear from 0 to 4 pi. So we click this setting. We go to the basic here and x minimum is 0. Actually 4 times 4 pi is 12.57, around 12.57. And then for y minimum, let's say we set here -5 to 5 only. Okay, so then we click. You can see this is, so it will also appear the rest, but understood 12.5 something only, means that when we want to find the roots here, you can see for this one, you can see the roots happen at this location, this one up to here. Means that here, if you want to get the intersection point, that is the values of x when our function f cross this x-axis, we go to this a dot here. You can see we have intersect, and then you can click here the value. So you can see this is the value, and then here, okay, you sorry, this one, okay, you can get the value for the next one. So this one, I delete it. And then here, also the intersection point. And then this one, 6, and here. So now we have all the values that cross x-axis, which is 0.79, 1.18, 2.75, 3.93, 4.32, 5.89, 7.07, 7.46, 9.03, 10.21, 10.6, and 12.17. And these all actually are roots for this equation, because you can see your function of f here are 0 for all these x. Means that this one will put here the solution. These are all the solution. But actually class, this one is slightly have a run-off error. It is okay. You can run off to up to 2 decimal places. Okay. If you go to this example 6 actually is about applied problem. For this one, the velocity of a free falling parachutist we can write in terms of this function. And the question asks you to use graphical method to determine the drag coefficient C for a parachutist of mass here. At mass is given 68.1 kg and the velocity is 40 meters per second after free falling for time 10 seconds. And also we have gravity. What does it mean by all this term? If you see here in this equation, you have to find the the velocity of free falling parachutists is given by this one, means that this V represent velocity. And then here we have G, so this one is gravity, and this M is mass. And then this C represent drag coefficient, and also we have here time. In this case, the question asks you to use graphical approach to determine drag coefficient needed. Means that you need to find C. When you need to find C, you have here function of C. And to have this function of C means that you have to make this equation equal to 0. Okay, because in this case we want to find the value of C when this function of C equal to 0. How to do this? So we have this kind of term. We rearrange this equation such that this function equal to 0. How to rearrange? To rearrange this one, you can move this V to this side. Or you can move also all these terms to this side. But to make you easy, you just move this V to this side. You will have your function of C equal to Gm, but G is gravity, is 9.8. So we can substitute, which is 9.8 times M is given by 68.1. So times 68.1 divided by C. C, we don't know the value. We want to compute the value of C now, which is times 1 minus exponential of negative, again C, we don't know the value, divided by M, 68.1 times T. And T is given here 10 seconds. Means that times 10, and then this one will be minus with V, but V here is velocity, which is given by 40 meter per second, so minus 40. That's why, class, you will have here this equation. Okay, to determine the root of the drag coefficient C, we need to solve this function of C equal to 0. How to solve this? The question asks you to use graphical approach. So now, for this case, I want to show you how to plot this graph manually, because I want to make sure that you understand why we need to go to another method of incremental search. So here, previously we have a function of C equal to 9.8 times 68.1 divided by C, and 1 minus exponential of negative C divided by 68.1, which is time 10, and then all this minus 40. So class, this C, we can set it, we can form a table. For example, this C is X. Okay, this one I changed to C, this one is f of C. So now, see, we can choose any value. Let's say I choose here, I cannot choose value 0, because when we choose here value 0, you will got here undefined function, because there is division by 0. So let's say we can start with 1, 2, 3, and 4. But here, I directly start with 4 here. When I choose this C equal to 4, okay, when this C, I change it to 4 here, and then I use my calculator to solve this, I will got 34.115. And then when this C I change to 8 and I use calculator to solve it, I will got 17.653, and so on. And based on this table, you can transform into graph, which is here you will have this one is C, this one is function of C. C, 4, 8, 12, 16, and 20. And we have here when 4, it is value 34 point, let's say it is somewhere here. Let's say here is 34.1125, and here is 17 point something. And this one is, for example, here at 6 point something, somewhere here. And then it go on 16, it go to the negative. Let's say here is negative 2, and next for 20, negative 8 point something. So when we plot this graph, for example, class, you will got this kind of figure. And This one is not exactly the graph because actually it is not really on the correct, because this one is just cache of the graph. So actually the root happened here. Okay, the root happened here. When this root happened here, you can see based on this, actually you also can substitute this one equal to 0, you can find the value of c, but we use graphical method, so the root is somewhere here. And if you plot using software like GeoGebra, you can get directly the value when f equal to 0. So now class, based on this, what I can conclude, this is actually the actual graph. We can see here the root happened at the point 15. So now we can see when 12, it is actually positive value. This one is when 12, let's say somewhere here, the value of f is 6.0670. When f is 20, somewhere here, you can see the value is negative 8.4010. In between this 15, which is 12 and 20, for this 16, we can see the root is negative 2.2690. This one is positive sign, this one is negative sign, and we can see when the sign changes, graph will cross x-axis. Okay, I repeat, when the sign of the value for the 12 is positive and sign of the value for the 16 is negative for f function, you can see here you will have a root in between these two values. Means that when function have here opposite sign, the root will be in between these two value. The root will be in between 12 and 13. From the graphical view here, we can get the idea. The root exists between c equal to 12 and 16, where the functions f12 here, this one f12, and f16 here have opposite sign or change its sign, which is when we multiply this both, you will got the value less than 0. Let's say if you have, for example, graph like this, the same thing happen. This one is the root, but here the graph is positive and here is negative. Means that you can see it change its sign, so we can ensure that in between these two x value there is root here. From here, class, mathematicians go to the incremental search. We no longer use graphical method, but we go to the incremental search. How can we find roots of equation? So the next subtopic that you will learn is you'll go to the incremental search to find roots of the equation.